Okay, good day everyone. So this will be your hydraulics. We will have another topic which is relative equilibrium of fluids. So let us try the definition. No? As for the definition of your relative equilibrium, it is a condition where the whole mass of a liquid, including the vessel in which the liquid is contained, it is moving at a uniform accelerated motion with respect to the earth. So going back to your dynamics, take note you have three types of acceleration. You have acceleration at rest, acceleration when it is constant, and acceleration when it is varying. So the acceleration that we are going to talk here is with respect to the Earth. Ibig sabihin, that is your gravitational acceleration, which is 9.81 meters per second squared. But every particle of the liquid have no relative motion between each other. So note that if a mass of a liquid is moving with a constant speed, the conditions are the same as static liquid in the previous sections, which is yung previous pinag-usapan natin sa fluid properties ninyo. Okay, so we have two cases for the relative equilibrium of fluids. First is that you have your rectilinear translation. So pag sinabi natin rectilinear translation, no, more of the examples of this or the principle of this is pag-usapan natin using the moving vessel. Okay, and sa moving vessel natin, you have your horizontal motion, your inclined motion, and you have a vertical motion. Okay. So pag sinabi nating translation, no, it means it is the whole mass with respect to the acceleration. So dito may pakilala ako sa inyo, which is I think nakilala niyo na during your dynamics, which is CREF, where your REF is your reverse effective force, no? Reverse effective force is the opposite motion of your acceleration. Like for example na lang, no, meron tayong track dito. Tapos yung track natin is moving horizontally, no, moving towards. Now that is your acceleration. So as definition, your reverse effective force is the opposite motion or opposite direction of your acceleration. So if your acceleration or if your vessel is moving to the right, ibig sabihin your reverse effective force is on the opposite side. So, para mas madali ninyong maintindihan what is the reverse effective force, ang example na lang nito is kapag sasakay kayo sa jeep, no? Kung sasakay kayo sa jeep, ibig sabihin at rest pa yung jeep, no? Pagkaupo ninyo, when the jeep suddenly move or has a motion, di ba it moves horizontally papunta sa right, ano yung nangyayari sa inyo? Diba yung nangyayari sa inyo is para kayong umaatras, no? Gumagayan yung motion ninyo. If the bus is going at this point, kayo na nakaupo, yung motion niyo is para kayo nagtitilt, no, opposite to the direction of the movement of the jeep, no, sayo na, no, that is because of your reverse effective force, no, because the movement of your reverse effective force is opposite to the direction of your acceleration. No, I hope I'm making sense, no, by that one. Another case for your relative equilibrium is your rotational translation, no? That is your rotating vessel. So, pag-uusapan natin yung open cylindrical vessel and closed cylindrical vessel. Okay? First, let us try to define your horizontal motion for rectilinear translation. No? According to this, if a mass of a fluid moves horizontally along a straight line at a constant acceleration A, the liquid assume an angle theta on the horizontal. So, for an instance, meron kayong track dito, no? When your track or your vessel, when your track or your vessel is at rest, di ba yung fluid niyo is stable pa? Ganyan pa siya, originally, no? Nung at rest pa yung vessel niyo. Nung in-applyan natin to ng acceleration, di ba ang mangyari is mag-move siya opposite to the direction of your acceleration. So, ibig sabihin, yung tubig ninyo, nagtitilt siya or magtitilt siya into this motion. No? Ibig sabihin, from horizontal position, naging incline yung position ng inyong fluid. And that is why nagkakaroon tayo ng angle theta. And your angle theta will recon from your horizontal papunta sa incline. Okay? Ibig sabihin, kinukuha natin yung inclination of your fluid nang dahil sa acceleration. Okay? So since you have a mass of liquid inside your vessel, therefore, meron tayong weight na pinag-uusapan, and that is mass times gravity. Okay? And because of your acceleration, again, ano yung nabubuo ng dahil sa acceleration? Meron tayong reverse effective force. And the formula of that one is mass times acceleration. So, to satisfy the equilibrium, meron tayong N dito, which is your normal force that is perpendicular to your surface. That one. Okay? So, to use the Allenberg's principle or to sum it up all the forces, no? Like para sa ginagawa sa statics ninyo, where gumagawa tayo ng free body diagram or ng diagram sa lahat ng forces ninyo. Okay? Downward force, that is your weight. Your horizontal force, that is your reverse effective force. And your inclined force is your normal force. So, kung hahanapin natin yung value ng angle theta ninyo, you can use the SOHCAHTOA kasi right triangle naman to. Okay? So, we will use tangent of theta is equals to reverse effective force divided by the weight, opposite over adjacent. So, we know that your reverse effective force is mass times acceleration, while your weight is mass times gravity. Therefore, mass here will be cancelled. Ano na lang yung may iwan? That is tangent of theta is equals to acceleration times g. So, take note of this formula, no? Magagamit natin to kung angle theta and acceleration yung hinahanap natin. Okay, ano pa ba? Meron pa ito. Tangent of theta is equals to y over x. Kailan ba natin yan masasabi? No, that is when kino-consider natin yung center line ng vessel ninyo. Ibig sabihin, from the center line, papunta sa point na to, this is distance x. This is distance y. This is also a theta. Okay, so ibig sabihin, nagagamit natin itong tangent of theta is equals to y over x kapag center line yung ating pinagbabasihan. Okay? Sana, no, nag-gets mo yan. Okay, so let us try this example. So sabi dito, you have a tank that is 5.2 meters long and 1.3 meters wide and 1.5 meters high. And it contains 0.9 meters of water. Okay, it is acted by an unbalanced force of 10.2 kilonewton parallel to each sides. Okay, so find the acceleration, find the force acting on the greatest depth and on the smallest depth. First question is your acceleration. So ano pa lang ba yung formula na kilala natin? No? The formula that we derived a while ago, that is just tangent of theta is equals to acceleration divided by the gravity. But then, kung ito yung formula na gagamitin natin, we have two unknowns. Hindi natin alam yung angle, hindi din natin alam yung acceleration. But take note, binigyan tayo ng unbalanced force. So what is unbalanced force? So take note that reverse effective force is also called as unbalanced force. Okay? That is unbalanced force. And we know that reverse effective force is mass times acceleration. So using this formula, we can get the value of your acceleration of the tank. O, paano ito naging ito? Bakit mass density times volume times acceleration? It is because no fluid man to, water man tong nasa loob ng tank natin. So we know that mass density is equals to mass over volume. Okay, laruin natin, i-derive natin in terms of mass. Therefore, your mass is equivalent to mass density times the volume. And take note, yung volume na pinag-uusapan natin dito is the volume of the fluid. Okay? So, since acceleration mo yung hinahanap natin dito, divide both sides by rho v. Divide both sides by rho v. Cancel. Cancel. Therefore, your acceleration is Reverse effective force divided by your 1,000 unit weight of water, mass density of water times the volume. Okay. REF is equals to 10.2 kilonewton times 1,000 para maging 10,200 Newton. So in terms of Newton to, 1,000, that is kilogram cubic meter. Volume, that is cubic meter. Okay, ano ba dapat yung unit ng ating acceleration? No? The unit of your acceleration should be meters per second squared. Parehas na lang sa gravity ninyo. Di ba yung gravity ninyo is acceleration ba yan? That is 9.81 meters per second squared. So, paano mangyari yun? No? Cubic meter, cancelled. Ano ba yung Newton? Di ba yung Newton is kilogram meters per second squared. So, cancel yung kilograms, may iwan is meters per second squared. Okay, kaya kinonvert natin yung kilonewton to Newton. Kasi kung kilonewton to, hindi natin makukuha yung unit. Okay, so do your calculation, and I guess the value for your acceleration of the tank is 1.676 meters per second squared. Okay, so to continue, let us try to find the force acting on the greatest depth and the force acting on the smallest depth. So we know that the formula of your force is, ano bang formula ng force natin? No? The formula of your force is pressure times the area. But since ang pinag-uusapan na force natin dito is your hydrostatic force, therefore, yung pressure natin dito should be hydrostatic pressure also. And that is gamma H. So to simplify, F is equals to gamma H times A. So balikan natin yung tanong. Hinahanap yung force acting on the greatest depth and the smallest depth. Ibig sabihin, we will have F max and F min. Okay? Matatawag natin itong F max if your H is maximum, at matatawag din natin itong force minimum if your H is minimum times A. So, paano ba natin malalaman yung value ng H natin? Ganito yan. Okay? Diba, meron tayong tangke dito, or you have your vessel here. Yung vessel ninyo, binigyan tayo ng acceleration ng 1.676 going to the right. Ibig sabihin, because of the reverse effective force, yung fluid inside the vessel, gagalaw sila. No? Gagalaw sila opposite, para na sumayaw. Gagalaw sila opposite to the direction of your acceleration. Ibig sabihin, from stable, yung tubig ninyo, nag-i-incline siya. No? Kasi gumalaw yung ating tubig. Okay? So, ibig sabihin ba niyan, yung tubig ba natin dito on the left side of your vessel is nadagdagan? Yes, kasi nag-move yung tubig natin. No? Kung i-imagine lang ninyo. While, on the other hand, dito naman na tubig natin is nabawasan. Parang ganito kasi yung nangyari, oh. Drawing ko, ah. Yan yung vessel. Ito yung original natin na height. Ay na height ng tubig. Yan na nga. Tapos, because of the acceleration, no, 1.676, okay, nag-move yung ating tubig. Pag-move ng tubig natin, naging ganito, no, nag-incline siya. Ibig sabihin, the total height ng tubig natin dito on the other side of the vessel is nadagdagan. That is your H max. Now, dito naman sa tubig natin, from original 0.9, nag-move nga yung tubig natin, ibig sabihin, nabawasan siya. Ito na yung H min natin, no? Pag gamitin niyo yung imagination ninyo kung ano nangyari dito sa tubig, no? Sana ay making sense sa inyo. So, ibig sabihin, kinakailangan natin makuha yung value ng Y, no? Yung value ng pagtaas ng tubig ninyo with respect to your acceleration. Okay? So, paano natin makukuha yan, no? Alam natin that tangent of theta is equals to y over x using your center line. Tama ba? But we also know that tangent of theta is equals to acceleration divided by the gravity. Since the same tangent theta to, pwede natin i-equate yung dalawang equation, no? And that is y over x is equals to a over g. So in this case, pwede natin makuha yung value ng y ng pagtaas ng tubig natin dito on the other side of the vessel. Therefore, y is equivalent to 3, that is not 3, no? That should, erase ko na lang lahat yan, pagkita natin dito. No? So that would be y over x, a over g is equals to y over x. In terms of y, no, kung i-cross multiplication natin yan, your y is equivalent to ax over g. No, I hope naintindihan niyo yan. No, cross multiplication lang naman. So y is equals to ax over g. Kunin natin yung pagtaas ng tubig because of the acceleration. Okay? Upon solving a while ago, your acceleration is 1.676. Yung x natin, kung centered line yung pagbabasihan natin, that is 5.2 divided by 2 times 9.81. Okay? And the y na makukuha natin dito would be 0.445. Okay? I want you to look at this. Okay? Di ba yung vessel natin is open? So, pag open yan, if sobrang lakas ng motion natin, ibig sabihin, maging malakas din yung reverse effective force natin. Reverse effective force natin. Ibig sabihin, may tendency na matapon yung tubig kasi open nga yung tangke ninyo. No? So, ngayon, titingnan natin if itong acceleration na 1.676 is magkakaroon ng spillage sa ating fluid inside the vessel. Paano ba natin malalaman yon? Okay, your y is 0.445. So initially, balikan natin tong ating diagram. Initially, ano ba yung height ng air natin nung wala pang movement yung ating vessel? Diba? That is 0.6. Paano naging 0.6 yan? The total height of your vessel is 1.5. Okay? The height of your fluid, the height of your water is 0.9. Sabihin natin, this is y air. So 1.5 minus 0.9, your y air is equivalent to 0.6. At nakuha natin na y a while ago, that is 0.445. Compare natin silang dalawa. Okay? Y is lesser than your y air. If your y is lesser than your y air, therefore, there is no spillage. Bakit there is no spillage? Kasi hindi pa umabot yung tubig ninyo para lumabas siya sa vessel. Paano? Hindi nyo naintindihan yun? Ganito lang. No? This is the original height of your water, which is 0.9. Ang height ng inyong vessel is 1.5. Ang height ng inyong air, ang height ng air ninyo is 0.6. And because of the acceleration na 1.676, nagkaroon ng reverse effective force, yung tubig ninyo is gumalaw. Tama ba? Okay? Nung gumalaw to, nadagdagan tayo ng y dito. Yung y natin is 0.445. So from here, nadagdagan tayo ng 0.445. At ito yung fluid na natin ngayon. So nakita nyo, hindi pa lumagpas yung tubig natin sa vessel ninyo. Therefore, wala pa tayong spillage. Nagets ba yun? No, sana ay making sense. No? 0.445. Tapos ang height naman ng air natin before magkaroon ng spillage is 0.6. So, ibig sabihin, pagbabasihan natin ngayon, if there is spillage or wala, is yung y ninyo or yung height ng inclination ninyo at yung height ng air ninyo. So, therefore, in this case, there is no spillage pa. Okay? So, kunin natin ngayon yung value ng inyong H. Okay? So, the original height of your fluid inside your vessel is 0.9. So this one will be your H mean, your Y mean, and your Y max. Kunin natin yung inyong Y max. Tama bang sabihin, on the greatest depth, kasi hydrostatic force yung kinukuha natin dito, di ba? Ito yung force na yon. This is the F1, and that is the F2. So the greatest depth, kung saan yung mas mataas yung depth ng tubig. Okay? Kung kukunin ko yung Y maximum, tama ba na sabihin ko, that is 0.9 plus yung tinaas ng tubig natin because of the acceleration, which is Y is equivalent to 0.445. No? So therefore, Y max is equal to 0.9 plus 0.445, and that is 1.345. Using the formula of your hydrostatic force, that is gamma H bar times A. So you have 9.81 times 1.345 divided by 2 times 1.345 times 1.3. So take note, this is the wide, or this is yung into the paper ninyo. So that is equivalent to 11.535 kilonewton. Okay, paano naging kilonewton to? No? Take note that 9.81, or your unit weight of water, that is kilonewton cubic meter. This is meter, meter, meter. This is equivalent to cubic meter. Cubic meter here and cubic meter here will be cancelled, and naiwan na unit will be in kilonewton. I hope I'm making sense. Okay? How about for this smallest depth? Okay, kukunin lang natin yung value ng Y mean ninyo. Okay, so tama ba? Para makuha natin yung value ng Y mean ninyo, that is the total height of your water, 0.9, minus the value of your Y. Ito, Y man to. No? Yan man yung pagkabawas ng tubig natin, kasi yung tubig dito is napunta dito because of the acceleration. No? So that is 0.9 minus 0.455, and that is 0.455 meters. So to get the minimum or the hydrostatic force from the smallest depth, that would be 9.81 times 0.455 divided by 2 times 0.455 times 1.3. And that is 1.32 kilonewton. So hindi ko na i-prove dito yung ating unit. Okay? So, balikan lang natin konti. Recap lang tayo, no? First thing na gagawin natin dito is to check if there is spillage sa binigay na acceleration ninyo. Paano natin nalalaman or paano natin masasabi if there is spillage or wala? I-compare natin yung Y na nakuha ninyo sa Y ng air. Okay? If your Y is lesser than the height of your air, no, at your initial situation, therefore there is no spillage. But if your Y naman is greater than the height of your air, no, therefore meron tayong spillage. So if that is the case, meron tayong spillage, may natapo na tubig, ibig sabihin yung volume inside the vessel ninyo is magbabago na kasi nabawasan na yung tubig ninyo. No? And that will lead us to this type of example. Okay, so another problem. An open tank that is 3 meters long and 1.8 meters wide and 1.5 meters high and having a water of 1.20 liters. It is parallel to the pair of the longest. So determine the maximum acceleration without spilling any liquid. Ibig sabihin, hahanapin natin yung acceleration lang na tama na wala pang nasispill na tubig. No? Kasi open tank eh. So, movement or motion ng truck ninyo or ng vessel ninyo na walang matatapon na tubig. Okay? Kanina, nakuha natin yung value ng acceleration ninyo using your reverse effective force, that is mass times acceleration. But in this problem, bigay ba yung reverse effective force? Hindi. No, it's because, tingnan nyo yung letter B, hinahanap mismo yung reverse effective force. So we cannot use this formula. No, we cannot use your reverse effective force for this formula. But then, meron pa tayong isang formula to get your acceleration. At ano yun? Okay? that is your tangent of theta A over G. Another formula for your tangent of theta that is equals to y over x is kapag pagbabasihan natin yung center line. And take note, laging yung tandaan, okay? Kapag nag-base tayo sa center line ninyo to get the angle theta ninyo, matik yan, no spillage yung ating consideration dito. Okay? Walang spillage yan. Kasi kino-consider natin yung gitna ng vessel ninyo. Okay? So, tayo natin kunin to, equate natin. Since parehas naman tong tangent theta, equate natin yung dalawa. Ibig sabihin, that is A over G is equals to Y over X. So, basically, no, using your cross multiplication, pakita ko pa ba? Okay, that is A X is equals to Y G. A mo yung hinahanap natin, so divide both sides by X. Cancel, cancel. Therefore, A is equals to YG times X. Parehas lang naman yan. Okay? So, having that said, no, ano ba yung magiging value ng Y natin from your center line? No? Ano ba yun? That is 1.5 minus 1.2. Ito yun, yung triangle na hinahanap natin. That is 0.3. Okay? Divided by your X, kalahati nito from the center line. Therefore, that is 3 divided by 2. And for your, what we call this, and for your gravity, that is 9.81. So, doing the calculation, no, that is 1.962 meters per second squared. Meters here will be cancelled. Okay, so yung may iwan na lang is meters per second squared. I hope I'm making sense. Okay. So let us try to solve your letter B. Yung letter B daw, binigyan tayo ng acceleration na 1.962. No? 1.962. Since meron tayong acceleration dito, ibig sabihin, magkakaroon din tayo ng reverse effective force. And actually, reverse effective force is also called as unbalanced force. Okay? Because of the acceleration, magkakaroon ng unbalanced force. And we know that your reverse effective force is mass times acceleration. Okay? And we know that your mass is equivalent to mass density times the volume. Kapag walang acceleration, when there is no acceleration, wala din reverse effective force. Makes sense? No? So, ganun lang yun. So, mass density times the volume times the acceleration. So, you have 1,000, you have 1.2 times 1.3 times 3. And again, okay? Again, ang volume is the volume of your fluid inside the vessel, hindi volume ng vessel. Okay? That is why you have 1.2. Height ng tubig ninyo, 1.2 times 1.8, yung wide, and 3 is the length. Times the acceleration, yung nakuha natin a while ago lang. Okay? So therefore, force is equivalent to 12,713 Newton. So makukuha niyo dito is Newton. No? Bakit Newton? Meters, 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 that is cubic meters. Cubic means meters cancel. Cancel, anong naiwan na unit? That is kilograms times meters per second squared. Ano ba yung kilograms meters per second squared? That is Newton. That's why you have this. Okay? So divide 1,000, magiging 12.714 kilonewton. But then again, yung problem, hindi naman siya strict if Newton or kilonewton. So pwede na tayo dito sa Newton. Okay? Okay, letter C tayo. The volume of spilled if accelerated at 3 meters. So, kiniklaim niya dito, nung inaccelerate natin yung vessel natin into 3 meters per second squared, may natapon na tubig. At yung hinahanap natin is the amount of volume na natapon na ng vessel. Okay, so meron na daw natapon. Parang ganito yung nangyari. No? Ito yung vessel natin. Ito yung tubig natin at rest muna. Naglagay siya ng 3 meters per second squared na acceleration.
may natapon na daw na tubig, no? Exaggerate lang tong drawing ko. May tubig na daw na natapon. Okay? So, ang hinahanap natin ngayon is itong volume ng tubig na natapon. Okay? So, sabihin, i-prove muna natin na at a given acceleration of 3 meters per second squared, may natapon na talaga. No, paano ba natin i-check yan if there is spillage? Diba? Sabi natin, if y is lesser than your y air, there is no spillage. No spillage. Okay? But if your y is greater than your y air, may spillage na. So, i-prove natin na may spillage talaga. No? Kasi hindi tayo pwedeng mag-assume agad. No? Kailangan natin i-prove talaga. No? Ganun naman tayo mga engineers. So, sige, paano natin yun i-prove? No? We will use your tangent of theta is equals to a over g is equals to y over x. Kunin natin yung y muna ninyo. So, ano ba yung value ng inyong y air? Diba that is 0.3? No, that is 1.5 minus 1.2. Ito, huwag niyo sundin yung diagram na ganyan, ha? Kasi, ano naman yan, estimated lang man yan, no? So, you have your y air as 0.3. Kunin natin yung value ng y. So, dito, no, magbabago na yung value ng y natin, hindi na yung parehas kanina. It's because nagbago yung acceleration ninyo, no? So, ang mangyayari ngayon, ganito na. No? You have 3 as your acceleration divided by 9.81 is equals to y. Hahanapin natin yung value ng y divided by 3 over 2. Okay? Pagkikuha yung value ng y. And as per my calculation, no? Tingnan natin baka iba lang yung decimals ninyo, but it's okay. At least the principle lang yung ma-adapt ninyo. No? I got it by 0.459. So, yung y natin dito is 0.459. So, what is the conclusion here? That is greater than. So, if your y is greater than the height of your air, therefore, anong conclusion yun? There is spillage. Ibig sabihin, totoo nga na at a given 3 meters per second squared na acceleration, may tubig na ngang natapon or may tubig na ngang lumabas from the vessel. Okay? And take note of this, no? That the formula for your volume spilled, that is the volume initial minus the volume retained. Pag sinabi natin volume initial, no? Ito yung volume ng fluid ninyo nung wala pang motion, nung at rest pa, no? Tapos nung binigyan natin to ng acceleration na 3 meters per second squared, di ba may natapon na, exaggerated na tong drawing ko, okay? May natapon na tubig, okay? So, ang kinakailangan na lang natin hanapin ngayon is yung volume ng naiwan, no? Kung ima-minus natin tong dalawang to, makukuha natin yung volume ng natapon. Okay? Sige. First is that, kunin muna natin yung volume initial. So, that is 1.20, height ng tubig natin, 1.20 times 1.8, yung wide, yung lawak ng vessel, times 3 meters, which is the length. And that is equivalent to 6.48 cubic meters. So, check na tayo dito. Hanapin natin yung volume retained. Dito sa volume retained, we have two scenarios here. Okay, take note. Note that when there is spillage, when there is spillage daw, kapag minatapon na tayong fluid, we need to consider your y prime as the total height of the vessel and your x prime will be computed. Ma'am, anong ibig sabihin nun, ma'am? Okay? Kanina, kung naalala ninyo, yung sa first example natin, this is 0.9. Tapos, yung y natin is yung 0.445 only kasi walang spillage doon, no? So, sabi dito, when there is spillage daw, ibig sabihin, yung y prime natin ngayon will be the total height of your vessel. Bakit? Kasi nga, may natapon na. Ibig sabihin, yung height ng y prime natin ngayon is the total height of your vessel. Sana nagigets yun. Okay? So, since meron na tayong bagong y prime, magkakaroon din tayo ng bagong x prime. And we will try to get that one. No? Given the acceleration 3 divided by 9.81 is equals to 1.5. Again, saka lang tayo mag-consider ng height ng vessel kapag may spillage na. Okay, sana nag-make sense yun. X prime is equals to 4.905. Ganito yung nagiging itsura ng vessel natin. No? Ito yan. Diba yan yung at rest pa. Nung nagkaroon tayo ng 3 meters per second, may tumilapon na tubig, ganito na yung magiging itsura niyan. Yan. Diba yung total length natin is 3 meters only. Pero yung height daw ng x prime natin is 4.905. But totally, ang nakikita nyo lang naman is ito lang. Ito lang yung volume retained natin. Kasi itong point na ito na yung volume na lumabas mismo sa vessel ninyo. Okay? So, you need to understand this principle. Okay? So, sabi dito, if your x prime is greater than or equal to your L, your volume retained is H minus Y LW. Kasi parang na itong trapezoid. O, yan o. Ganyan na yung kanyang shape. Trapezoid na siya. Ito na yung volume retained ninyo. Okay? But when your x prime is lesser than L, no, that is 1/2 x prime, y prime, w. But for this problem, no, ito yung magagamit natin. Because as you can see, x prime is 4.905, while your L is only 3 meters. Therefore, that is greater than. So, alalahanin nyo na lang to, no, para hindi na kayo mag-ratio and proportion. Ibig sabihin, volume retained is 1.5 minus y times 1.8 times 3. So your y here is yung nakuha natin kanina, which is 0.459. Take note that is y, that is not y prime. That is y. No? So that is 5.621. Okay, so to get your volume spilled at the acceleration of 3 meters per second, that would be 0.859, that is not meters, that should be cubic meters. And that is your answer. Okay. Sige, kaya pa? Sabihin natin yan. Okay, letter D. Okay, so letter D, the volume of water retained when the acceleration is 5.4 meters per second. So kung kanina, no, yung problem natin, 3 meters per second squared lang yung acceleration, may tumapon na tubig. What more kung mas nilakasan pa natin yung acceleration natin? Ibig sabihin, mas may matatapon pa talaga na tubig nun. So kukunin natin ngayon kung ilan na lang yung naiwan. So in that case, by that case, no, ibig sabihin, magbabago din yung value ng y ninyo. Bakit magbabago yung value ng y? Kasi nagbago yung acceleration ninyo. I hope I'm making sense, no? So dito, i-prove pa rin natin na may spillage talaga. Okay? So this is 5.4 divided by 9.81 is equals to y 3 divided by 2. So what is the value of your y? Okay, so the value of your y, that is 0.826. Okay, and ano ba yung y air natin dito kanina? No, your y air is equivalent to 0.3. 1.5 minus 1.2. Ibig sabihin, this is greater than. If your y is greater than your y air, there is spillage. No? Okay. Naglalag. Sige, for a while. Okay, sorry for that. Nalobat pala yung ating laptop. Okay, so to continue, no? So to continue, ano na yung sinasabi ko kanina? Your y air, again, your y air is equivalent to 0.3. Okay? If that is the case, y is greater than your y air, therefore the conclusion here, meron tayong spillage. Okay? Kung meron tayong spillage, matik na that the height of your y prime now will be the height of your vessel. Okay? So what would be your x prime? So kinakailangan natin kunin yung x prime natin. And that would be x prime is equals to y prime g over a. So kahit hindi nyo ito memorize yan, ano nyo na lang, kahit na mag-shift solve kayo, okay lang naman. No? That is a over g is equals to y prime over x prime. Dinerive ko lang to para wala na shift solve. No? But then again, that is just 5.4 divided by 9.81 is equals to 1.5 over x prime. Ano ba yung x prime na nakukuha ninyo? No? Based on my calculation, that is 2.725. And that is your x. Ano ba yung sabi natin dito? No? If your x prime is lesser than your L, therefore, your volume retained is 1/2 of x prime y prime times the width. Paano nangyari yun, ma'am? Paki-explain, ma'am, kung ano yung figure namin. Ganito yan, no? If this is your vessel, no? Your vessel is 3 meters. Yan yung length natin. If our datum is dito sa left, okay, papunta dito sa right, that is, yung x prime daw natin is only 2.725. Ito na lang yung naiiwan na tubig natin. No, anong shape ba to? That is triangle. That is why your volume retained is 1/2 of x prime times y prime times the width. Ito naman yung y prime eh. Sana nagigets yun? Kasi yung ibang tubig, kaya wala ng tubig dito kasi wala na. Nabuhos na siya, natapo na siya sa vessel. Okay, sana nagigets yun? So that is why your volume retained for this problem is 1/2 of x prime y prime times the width. So, pause nyo na lang, no? Para mag-try nyo yung calcu. And the answer for that is 3.679 cubic meters. Okay. Sige, so that's it for your horizontal motion. So let us go to your vertical motion, no, for your rectilinear moving vessel. Okay, so normally, itong vertical motion ninyo, no, if you will try to imagine kung paano nangyayari itong vertical motion ninyo, is para lang tong elevator, no, na yung vessel ninyo, hinahila pataas, tapos hinahila rin pababa. No, itong vertical motion ninyo is mas madali kasi pressure lang yung hinahanap natin dito. But let us try to derive the formula. Okay? So you have an acceleration dito. So your vessel is moving or moving upward, no? Kasi yung acceleration niya is pataas. So when we have acceleration pataas, ano yung reverse effective force natin? That is going downward. Kasi nga, salungat. Magkasalungat yung acceleration at yung reverse effective force. Okay? Since you have a fluid inside your vessel, meron tayong weight na i-consider. And that is mass times gravity. So to satisfy the equilibrium, no, you have a normal force where your normal force is pressure times acceleration. So kunin natin tong formulas out of these three forces. Okay? So what we are going to do here is summation of forces vertical, upward will be positive. So you have normal force minus weight minus REF is equals to 0. So to simplify this one, normal force is equals to weight plus reverse effective force. You all know that your mass, or I mean your weight is mass times gravity, no? So, weight is mass times gravity, okay? Your reverse effective force is mass times acceleration. So, alam natin that your mass is also weight over gravity. Transpose natin yun. Ito yung magiging itsura. Weight, ito, Ito na nangyari sa mass ninyo ngayon. Naging weight over gravity, naging weight over gravity. Cancel natin yung gravity. Ano yung naiwan? Yung naiwan na lang is normal force is equals to weight plus weight over the gravity times acceleration. Okay? But we also know na yung weight natin is nakikita natin sa inyong weight density. No? Sa weight density ninyo, where your weight density is weight over volume. Kung i-derive natin yung formula in terms of weight, that would be gamma volume. Okay, are you with me? And you know that volume is area times the height. Okay, so transpose natin yan. Palitan natin yung W. Palitan natin ng W ng gamma AH. Itong AH, that is your volume. Okay, palitan natin yan. So, ibig sabihin, you have gamma AH plus gamma AH over G times acceleration. Ma'am, anong nangyari sa NF? Or your normal force, di ba? The formula of your force is pressure times acceleration. Binago ko lang. Okay? Factor out natin yung pareho. Okay? Pressure times area. Di ba lahat to is merong gamma AH, may gamma AH din to. So, factor out natin, ilabas natin yung ating equation. So, gamma AH is equals to 1 plus A over G. Parehas lang naman, di ba? Kapag yung gamma AH, i-multiply natin dito, ito lang naman yun. Gamma AH, multiply natin ulit dito, ito lang ulit yun. Finactor out lang natin. Okay? And as you can see, your area here will be cancelled. Area is cancelled, area is also cancelled. Ano yung maiiwan? That is just pressure is equals to gamma H 1 plus acceleration divided by G. And this is our formula for your vertical motion. Okay? I hope you understand kung paano natin dinerive yung inyong formula. But take note, no? Kapag vertical motion, the formula of this talaga is pressure is equals to gamma H 1 plus minus acceleration times the gravity. Bakit plus tong ginamit natin kanina? Okay? Because take note, ang pinagbasihan natin is that your moving vessel is moving upward. So when it is moving downward naman, therefore the symbol is just negative. Okay? So I'm making sense. Sana naman. Okay. So let us try this example. No? So you have a vessel here, a closed vessel or a closed tank. Bakit ko nasabing closed tank to? Kasi meron tayong pressure. No? That is 19.62. Kasi kapag open naman, wala naman tayong pressure na kinoconsider. So malamang sa malamang, closed itong tank na to or closed tong vessel na ito. So sa vessel na ito, meron tayong tatlong fluids. No? Meron tayong specific gravity na 0.8, 1, and 1.25. Okay? So according to the problem, let us try to get the total pressure of your vessel if it is moving upward with an acceleration of 3 meters per second squared. So ito lang yung formula natin. Okay? So initially, your formula is just gamma H1 plus A over G. So plus to, it's because moving upward. So saan nagaling to? So it's not always may pressure 1 tayo dito ha. Nangyari lang kasi meron tayong pressure na binigay sa problem. Okay? So get that one. That is 19.62 times gamma H. Gamma H tayo. First is that this one. 9.81.8 times 2. 9.81 times 1 times 3. Ito yon. 9.81 times 1.25 times 4. Ito yon. Okay, that is your gamma H. At huwag niyong kakalimutan yung bracket natin dito before your acceleration. Kasi normally, sobrang dali lang ng vertical motion. Ang problema lang kung mali yung pagkakalculate ninyo. Kasi minsan nakakalimutan itong bracket na ito, ang nangyayari, namumultiply natin itong term lang na ito. O mali na agad yun. no? So just make sure about the brackets na gagamitin natin for your gamma h. So times 1 plus 3 over 9.81. Therefore, your pressure, if your vessel is moving upward, that is 142.596 kPa. Okay? For letter B, how about naman daw if your vessel is moving downward with the same acceleration, 3 meters per second squared? So, the same lang naman. Ano nangyari, no? The same equation all throughout dito. Pero pag abot dito, nagbago. It's because negative na yung gagamitin natin. Bakit negative? Because that is moving downward. But the concept ng dalawa is parehas lang naman. So, can you check if that is 88.496? Okay, for a while. Okay, and that is in the unit of kPa. Pressure man, so that is kPa or kilonewton, kilopascal rather. Okay, so how about for your inclined motion, no, moving vessel? So ito, dito, parehas lang naman to yung concept nito sa horizontal motion. But the thing is, yung vessel natin is dumadaan na sa inclined plane ninyo, which is yung mga roads na pataas, kanang mga tungas na roads. No, yan na yung inclined motion ninyo. Where meron na tayong kino-consider na angle alpha. At yung angle alpha ninyo, yan yung inclination ng plane ninyo. Or sa mas madaling salita, yan yung angle ng road ninyo. Okay? But the consideration inside the vessel is the same, no? You have your angle theta that is recon to the horizontal, to the incline. Okay? So, kung i-Allenberg's theorem natin to, or to get the free body diagram, ganito yung magiging itsura ng right triangle natin. Nadagdagan lang tayo. Ito, nadagdagan lang. It's because yun na nga, incline na yung plane natin. Okay? So, get natin. So, kunin natin yung angle theta na ninyo using SOHCAHTOA, which is tangent theta. Okay? Tangent, that is opposite over adjacent. Okay? That is x over w plus y. Okay? So, okay. Sobrang init sa tagtubig. No? Okay. So, bakit naging ganito yung equation natin? Why do we have MA cos alpha? No, this is alpha. This is alpha. MA cos alpha and sine alpha. Bakit tayo nagkaroon ng ganyan? It is because of your inclined plane nga. No? Itong inclined plane ninyo. Ito yon. So, try natin i-isolate itong triangle ninyo. Isolate ko yan. Kapag in-isolate ko yan, ganito yung itsura niya. This is your alpha, this is your y, this is your x, and this is your REF or reverse effective force mass times acceleration. Kukunin ko yung value ng x ninyo with respect to your hypotenuse. So, ano yan? So, SOHCAHTOA. Tama ba na that is cosine? No? So, cosine of, ano ba yan? No? So, cosine of alpha is equals to adjacent over hypotenuse. Cross multiplication. Therefore, x is equals to mass acceleration cosine of alpha. Ito yun. Kasi yan yung value ng x ninyo. Weight or your W, alam naman natin yan, na that is mass times gravity. Kunin naman natin tong MA sine of theta kasi y daw yan. O, kunin naman natin. Ito naman yung na-triangle yung pagbabasihan. And that is opposite over hypotenuse, which is that is sine of alpha is equals to y over mass times acceleration. Therefore, your y is mass times acceleration sine of alpha. That is why y is ma sine of alpha. I hope I am making sense. Okay? So, simplify natin to, magiging ma cosine of alpha, factor out ko yung mass kasi parehas lang naman yung sa denominator, no? Mass is equals to gravity plus a sine of alpha. Ano yung makukonclude natin dito? Mass will be cancelled. Okay? So having that said, the formula for your angle, for the inclination of your fluid inside the vessel, that is a cosine alpha divided by g plus a sine of alpha. And take note, okay, take note of this, that should be plus and minus alpha. Kasi pag derive natin ang formula nito is going upward man yung ating vessel. So paano kapag bumaba siya or umatras siya? So that is negative. Excuse me. Okay? So that is AH over G plus minus AV. Yung AH lang mo, that's just a cosine alpha. Your AV, that is just a sine of alpha. So, sa inclined motion is formula-based lang din tayo pareha sa vertical motion. Okay? Yung medyo mahirap lang talaga yung principle is yung horizontal motion only. Okay? So, this is the problem. Okay? So, a vessel containing an oil is accelerated on a plane incline by 15 degrees with the horizontal at 1.2 meters per second squared. Determine the inclination of the oil surface when the motion is upward. Ibig sabihin, pataas daw yung vessel natin sa inclined plane ninyo. Kunin muna natin ano yung given, no? So, for the given, no, you have an acceleration given that is 1.2 meters per second squared. Paano ko nalaman na acceleration yan? Tingnan nyo naman yung unit, meters per second squared. Ano pa yung binigay? Yung binigay pa is the angle of inclination of your plane. Ibig sabihin, yung plane ninyo, yan yung road ninyo. No? Kung flat to, naka-incline daw yung plane ninyo by 15 degrees. So, sino yung 15 degrees? Is that the alpha or the theta? Alpha, ma'am, kaya nakita na namo diri. No? But actually, that is correct. That is alpha because that is the inclination of your plane. It is correct. No? So, therefore, alpha is 15 degrees. Ano ba yung tinatanong dito? Determine the inclination of the oil surface when the motion is upward. So, originally, no, nung hindi pa tumataas yung inyong vessel, nung atras pa siya, ganito pa yung oil ninyo, no? Nung dumaan siya sa inclined plane, naging inclined din yung ating tubig dito, and there is motion, no, recon from the horizontal to the incline, ito yung hinahanap natin, which is your angle theta. No? Pero di tayo mas scared kasi formula-based lang naman tayo dito. And that is a cosine of alpha. No? That is a cosine alpha divided by G plus sine alpha. Again, bakit plus to? Because that is moving upward. Kung pabalik yung movement ng ating vessel, that is negative because nagde-decelerate yung inyong vessel. Okay, so that is 1.2 cosine of 15 divided by 9.81 plus 1.2 sine of 15. And that is equals to 6.536 degrees. Okay, so subukan nyo na lang sa calculator ninyo, no, if that is the value na nakukuha niyo. Okay, so pwede naman shift solve, okay lang, or you can use the arctan. No, kapag nag-arctan kayo, no, nakita ko kasi sa iba, nag-arctan nga sila, pero nag-x pa rin, tapos nag-equals pa rin, 1.2 cosine 15, mali na yun, no? Mali na yun. Kasi kapag nag-arctan kayo, no, kapag nag-inverse tangent kayo, kapag nag-arctan kayo, no, iniiwasan nyo lang yung shift solve. So, wala na kayong value ng x dapat dito. Okay? diretso na yan. Parehas pa rin yan. Kung nag-shift solve kayo ng tangent theta, kapag ganito yung equation nilagay nyo sa calculator. Okay? So, that's all for your rectilinear translation. So, we will try to move to your rotating vessel.